so I'm Marcel from Lohuizen. I'm the only one working on the Go team outside of the US. I've been working on the Go team for quite a while, actually, 2011. So today one of the main, I've done multiple things like the subtests and all that kind of stuff, but I want to talk on the Xtext repo mostly today and how it came about and what the philosophy is behind it and all that stuff. So a little bit of history. So I started on this quite long ago, 2011. Working on it 50%, so it's going slowly. I'm doing mostly everything myself. So Rob asked me to basically work on something that is to really rethink the way localization in I18N is done, to not really look at ICU too much, at the implementations, and to see, since we have a new language, if we can do things differently. Also, the APIs weren't very Go-like, so can we do things in a better way or easy way, because it's quite a complex matter. So there's other reasons though. So why write things from scratch? So point number one is basically, that already says it. So Go has a very high cost for bridging with C, which is kind of important with this I18N stuff. So to really to use like calls to ICU is kind of costly, and also for deployment and all that stuff, right? Running it on App Engine is kind of, it sort of won't work. So another thing is we really wanted to have like this Go-like API, and also the world has kind of been changing around. So if you look at, I'll come back to it, but if you look at Go applications, they're mostly servers, so you want to handle things there slightly differently, different requirements. And also most of the I18N and localization APIs were getting a little bit outdated. There's a lot of new data, a lot of new knowledge, a lot of new tools and possibilities, and the APIs just can't really deal with it very well. So we have to see if we can, like do something better. But since I couldn't really copy it from anywhere, it was a little bit tricky. Take some time. So what is different? Well, first of all, like at the very basic, like Go uses UTF-8. A lot of other languages use like UTF-16. So also the strings are quite simple, a little bit back to C. So the strings don't necessarily need to be normalized. There's no metadata to keep track of whether something is normalized or not. So you might think this is a problem. And one thing that people have objected to a lot with UTF-8 is the lack of random access. So let's look at that for a moment. So if you look at this example here, so I have a string with two emoji flags, a Korean and an American flag. And I skip like 4 bytes, so like 1 rune. What does anybody have any idea what this will print, by any chance? Okay. Go for the good answer. Yes.
It's Russian flag.
It is the Russian flag. Yeah, here you go. It's the Russian flag. So what's happening here? So basically what happens is a Unicode flag is actually 2 32-bit code points, or well, not 32-bit, but 2 4-byte code points. And so they're represented with 2 code points, each 1 code point for each of the letters in the country code. So basically I'm only skipping the K here. So the next one will be RU, which is Russia. There's no distinction between a start or an end code point, so like there you have it. So this has some implications though. So suppose I have an infinite sequence of Unicode flags, I might have to backtrack infinitely to see the start of a glyph even, right? So this is new with emoji flags, a pretty bad property of Unicode now, but so be it. The larger point here is, in general, this is an extreme example, but it's, you can give tons of examples. Text is inherently sequential. So the goal to do anything to get random access for code points, what Python does, is a complete waste of time, right? Like it's just overhead and it really doesn't help you. Actually, it can hurt you a lot. Suppose like you have ASCII only and then you add like 1 emoji in Python, all of a sudden your text will become 4 times the size. So another thing, like being server-centric. So so normally if you have an, in the old way, when you had desktops or even like with mobile apps, you have one application, you have one locale that the user uses. You load the data for that locale, and you know, everybody's happy. So on servers, it doesn't quite work that way. Basically, you're switching, serving different users all the time. So basically, you need to have all the locales handy, right? So ICU has been mostly designed for this first use case and really optimized for that. So you know, with Go, we started to look like, what can we do if we optimize for this second use case? So another thing that is very Go specific is statically linked binaries. So here again, so we already have to sort of link everything in anyway if we want to have statically linked binaries. So basically the whole goal here has been to, okay, can we have any structure sharing? Can we pack things differently, knowing that we need to include everything anyway? Can we do smart things, like if you don't use a certain table or part of a table gets dropped by the linker automatically, like a lot of that is going on, sometimes influences API design. And in general, like, you know, how do you optimize for this? So that's been one of the, you know, major designs. So another very cute one is streaming. So I want to be able to run like a Go server in, let's say, 100 megabytes of memory and dealing with gigabyte size files, and it should all work because we have all these nice readers and writers and we just stream everything. So one problem though is that normalization. So I don't know if you're familiar with normalization, but a Unicode string can be represented in many different ways, and they're logically the same string. So in order to deal with that, you have to normalize. So normalize is actually an n-squared algorithm, requires linear space. So that means that if you run this as a streaming algorithm in a buffer with traditional algorithms, you might blow up the server if you send the wrong string. So that's not good. So for Go, we implemented an order n algorithm. It's, as I know, the first implementation out there. It's slightly different semantics than original Unicode strings, but the Unicode standard does allow for it. They say the disadvantage of it is you cannot make it secure, but they're wrong. You actually can make it secure. This is a secure implementation. So, and you know, blowing up servers is not secure. So what do you want? So as far as I know, this is still the only implementation. So don't want to focus on this too much at this point in time, but Go-like API. So this is sort of how it will look like to do encodings or normalizations. It's if you compare it to some of the other APIs, it's quite simple. So another thing that was completely rethought is language identification. So you know, most people just take the first two letters of a BCP47 tag or however they want to call it. And then, you know, compare it to what other language do I have, match it, and then be happy. Except that this skips over a lot of different things. So, so most of the implementations out there aren't quite that good. Internally within Google, we had a pretty nice one, which the Go implementation is based on, but improved. And this is now being exported into the Java implementation. I still think the Go one is better. It's you know, we're sort of converging on it. I'm debating with Mark Davis all the time, like, you know, how we should do this. But so Go is, in other words, is leading with this whole language matching thing. So to give you some examples, that is not trivial. So if somebody asks for Swiss German specifically, language code GSW, you'd be very fine to serve them German. If a German asks for German and you serve them Swiss German, they will not be quite as happy. So the official language code for Mandarin is CMN, but everybody uses CH. You kind of have to know that. Croatian matches SR Latin, although it's, I think they might have removed. Angolan Portuguese is closer to European Portuguese than Brazilian Portuguese. So like all these kind of things you have to know, this is all baked in. Like if you just use the language matcher, nobody, you know, you don't have to worry about this stuff. It's all taken care of. It's actually much more complicated than this, but I won't bother you with it. So now this is a little bit the interesting thing, like a little bit the latest development, if you will. So localization API, so basically replacing or translating strings within your application, let's say. So what's the problem there? So even if you look at a lot of the file format for translations, they're very sort of English-centric, if you will, right? They only allow pluralization and maybe only one in a string, which is the common case, but still, right? But for French, it already breaks down. So here you have an example. So in English, this is, you know, person went to work. In French, this basically means you don't only need plural for this, you actually also need a gender for this. So of the list, for example. So in gettext, your soul, basically. So what else? So basically ICU has a solution for this. It's an extension, I think it was developed within Google. So the problem here is, so here it works, right? Like at the bottom line, you have the ICU representation for the French translation. There's two problems for this. So you kind of want for English, the programmer to encode this as well. So you basically force the programmer to become a linguist. They have to sort of know like which things to pass, and you force a linguist to become a developer. So this also has its drawbacks. It's actually a much nicer formalism than you might think. It's very compact. I'll give them that, but it's not. It's not, like it's a little bit complicated. So the point what I wanted to do in Go, so this is still very premature, but the whole design of the Go framework is that to make it as easy as possible for the linguists to add whatever attributes they need to add, but also to allow tooling to make it the translator simple, right? So it all assumes that I can programmatically expand all these different like sentences and derive basically which verbs I need to I can replace, which words to compact the translations as much as possible. I have a linguistics background as well, so that helps here a little bit. But this is very futuristic, but I can see that years down the line you can make much better translation tools. So this has been designed with that in mind, basically. So how would it look like in Go, for example? So like here, at the bottom you see a possible translation where you can say, well, I want to use. So I know I have to use this French verb here, and it depends on like the linguistic features of group. So it knows it needs plural, so it can derive the plural for it, it can derive the gender for it. So this seems like a little bit too magical, but in the Go framework, it actually has been designed this way. So if you pass it a list, it will know, okay, it has a cardinality. If the elements in the list have genders, it know what it means to derive the linguistic gender from a list, which is different for each language. But that data all exists in CLDR. It's just, most frameworks just don't use it yet, but the data is available. Here's another example, it doesn't really matter. So on the left hand, you have an ICU string for a very complicated example where I do think in this case, the programmer should probably program it instead of having it in translation strings. But on the right, you see how this can be encoded today in Go code, actually. So this is, again, like if you have some framework that's can figure out what to do, you can actually program it on the Go code. And the Go code is actually shorter than the ICU string, which is also kind of interesting. So ICU actually allows you to do a lot. However, it is still not powerful enough. So this is another problem. So this is, so if you look at, for example, spelling out numbers, so writing 3 as the word 3 instead of the number 3. So in English, you can do that in two different ways. You can look at the cardinal numbers or ordinal numbers. And so cardinal is just 1 and ordinal is first, right? So if you look at, and this is like nicely defined as a bunch of RBNF rules for, one category for each or one list for each. So if you look at Polish though, like just at cardinality, this is the number of rules, right? Like each of them has this whole expansion. So in yellow, you can hardly read it, but it's all the linguistic properties that it might depend on. So, it can be, I don't know, genitive, personal, dative, accusative, animate, whatever, instrumental, locative. So all these different properties depend on the context of the sentence, right? So basically somehow the translator will need to say, like, okay, this number that you're rendering here needs to be, it's accusative within this context. So as I said, the framework has been designed in a way so that you could use like grammars or whatever to derive this automatically and then inject it, right? Which in ICU is a little bit more tricky, but you could do that kind of stuff. So maybe we can automate it in the future. But anyway, it is possible to pass this kind of stuff along. So another key feature in doing this is that If you substitute numbers, instead of formatting your number in some number formatter and then substituting it in a string, you specify what is the type of number. Is it scientific engineering? Is it ordinal, whatever? And then you substitute it, and then the decision on how to render it is dependent on the context which it's substituted in the very last moment, right? So in practice, it turns out that choosing your format string depends on the number, yes, but how to format the number depends on the format string that you choose. So it's actually cyclic dependency, which drove me nuts for a very long time. So couldn't break out of the loop. So this is some of the design characteristics. Yeah, so basically, I think I discussed most of this. It's not that interesting. Let me just skip this. I also discussed this already. So I want to go down to a demo. So I'm going over this a little bit fast. So late decision, I already mentioned this. So if you look at the current status of packages, this is it. So if you look at the internationalization part, so preparing your and tooling around your application for, you know, like allowing multiple languages, it's pretty far along. For the actual pipeline of, you know, feeding your messages into a pipeline and getting it back, that's under active development right now. So dates are not implemented, working on it. So numbers are just implemented. So, you know, gender is designed almost there. BiDi is like this close to being done, but I don't think anybody will ever need it beyond what we have now. So I'm just really reluctant to implement it. Segmentation is a big pain in the butt. So I'm trying to see if the Unicode guys can release the data at a low level instead of the super high level, which would make life a lot easier. So a little demo of what is possible today. Is this going to work now? Let me see. Yes, so I have this little server here, which basically prints a number of days till Christmas. Very simple Go server. So I have here, maybe I should make it a little bit bigger, huh? So I have here, like, you know, compute the number of days. I have some options there. So here's the little, you know, like HTML template. And then very simply, like, I create a sentence that I will substitute in the template, and then I will run it. So let's see what it does right now. So here we go. Let me get this. So let's go to a browser. Okay. So we have this. There's 25 days till Christmas. So just to show you this, if you have a really large number, it looks like this. So nothing too fancy, right? So let's try to localize this now. So the first thing I will need to do is, as I said, I will need to do a language matcher. So the basic pipeline here is to say I need to do some instrumentation anyway. So I'll just implement it right now. And after I've done that, I use the nice Go instrumentation like Guru and types analysis and all that stuff to then figure out what needs to be changed based on what I've just done. So let's see how that looks. So so basically, I need to create a message printer. Wait, new printer. It's called. So what does it want? It wants a language tag because I need to specify the language. So usually what we do is we say we get accept language. So this is a normal thing to do. But really I want to be able to I'm not actually going to use that. So basically, let's say I want to have the lang here that I'm just going to pass on the line. And then there's this little thing. This is not checked in yet, but you know, it's very handy. So, and then it complains that this is not used yet, but that's the point. So basically the idea is that wherever I'm using format strings, and this is not implemented, but the idea is that it will use this data flow to get also constant strings that can possibly be passed to this printer end. But right now, wherever it uses FUMIT, and where there's a printer in scope, I will now localize this automatically. So one thing you should note here, if you look at FUMIT printf here, it uses a style of creating sentences which is really not conducive for localization. So to interleave strings with arguments, this is not really how you should do it. So let's see how this is solved. So we'll stop the little program. Then we do go rewrite. Not go, of course. Let's go text. Yes, that does something. So I'll just change it in place. Yes, so it gives this little error that P was declared and not used. That is correct. We just happily ignore that. And then if we now look at the diffs here, so we can see my changes. And then here it replaced the FUMIT sprint with a P sprint F. So you really should use the F for localizing strings. And it actually rewrote it to use substitution arguments and then put all the arguments at the end, right? So this is all done automatically. So let's see what happens now. So if we run it now. So nothing much changed, but maybe what if we use the 1000? Oh, right, now there's a comma all of a sudden. So even though we haven't provided any translations, it already does the proper formatting of numbers based on the language. So we got that for free, at least. But that's not enough. So now what I want to do is I want to extract the strings. So there's not many. There we go. So I want to extract the strings, and I'm also telling I want to localize for English, German, Dutch, and Bengali, just because Bengali is more interesting. So I generated a bunch of files to save some effort. I will copy some of the translated ones locally. Am I doing that correctly? Always the demo, right? Yes, I think so. So let's just see how they look like. So I have some messages here. So this is the basic one that's being generated. It has the original placeholders. You can see that basically it replaces, so for the translators, this is a string the translators will see. So it replaces all the printf substitutions with these nicer little elements. So it derives the names from the variable names, the type names. There's all these kind of heuristics to determine that. So right now the key is the message. What you can also do, so most frameworks say you can just use some nice or some coded string with a number. Here you can actually refer to a constant, and it will use the constant identifier, right? So at the language level as the key. So it also rewrites the substitutions to use like explicit argument numbers, all that kind of stuff, so that even if you reorder it, it can be substituted back nicely. So if you see some of the translation files, so here I have one in Dutch, in English, Bengali. So most of them are one sentence. So let's see what this does. So I first need to, as we want a static binary, I'll generate a catalog. Hope this works, and then like run this thing again. So let's see what this does. So I now have an exclamation mark, so that changed. But basically, if I now say I want the Dutch language, all of a sudden I get it in Dutch. Numbers are differently formatted. If I want to get it in Bengali, it looks like this with these illegible like Bengali numbers. And look at the comma setting. They have these logs things, right? So they go by 100,000 instead of a million. Very interesting. And then the English one is also kind of interesting. So if I now go back, so let's do the more, this is today. But what, for example, if we are 1 day away? Then it does this. So it also does the whole plural thing. So the encoding for that you can see right here. Right, it's so this is basically just a JSON format. It's pretty generic. This is not meant to be the files that you actually use for translation. So the idea is that you have encoders that write to xlib, PO files, getText, or whatever, L20N, and convert it back. But this is sort of the interlingua that Go uses with all the, like low-level information. So what I want to do right now is to build this whole pipelining infrastructure library that any of the tools that are already out there can use, or other tools. I'll create a simple toy tool myself, right, so that people can start localizing more effectively. So let's go back to this thingy. Really only have some references. So that's it pretty much. Are there any questions? Yes?
Do I need to deploy those JSON files with the application?
No, you don't. No, okay. No. And actually right now they're generated. So most of the applications have multiple steps, right, for generation, extraction, whatever. So the rewrite is a one-time thing, right? You don't usually do that. But what I basically want to get at is to have one command, which you just put as a go generate in your main file, right? And then it does both the extraction and the integration, whatever. So even the intermediate extraction files wouldn't be generated, right? Only the things that need to be sent to the translator, whatever that is, whatever. Yeah.
I think there's a way to extend like getText or something like that, because this is just amazing. When you work with a regular getText, it's just a mess. All this different stuff you said, like with the gender, you have to deal with new strings, new conditions. That just,
well, yeah. So the problem is you have multiple attempts at this. So Mozilla has a new standard. It's called this Fluent, and you have this L20N language, which is quite nice. It's pretty elaborate. They even solved the passing the higher linguistic properties like down, right? The problem there is again that it's a very complicated formalism, right? So what you really want is something that really dumps it down, right? Or at least have a tool that can sort of manage that complexity, hide it to the translator. So it's really something you need to design with in unison with tools and formalisms. But so there are formalisms that support all this, right? But then you have to find translators that can work with it. But yeah, I mean, if you can wait, right? Like one thing you could do is you could say, okay, I have, I know I need to expand to all these, different sentences. These are all the variants possible. So let's have 2 of them translated, get them back, try to generate all of them, and have then translators correct them again, right? So that's one thing. If the tools don't support it, right? Like the expansion and comparison, that's one thing you could do, for example. Yeah.
If I understand correctly, this approach actually allows you to have several locales supported in one application.
Yep. Mm-hmm. Yeah.
Because they have different features.
Yeah. 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 Go ahead. Oh, okay. Yeah.
Are there any kind of implementations for other languages?
For other languages. Yeah. Yeah. No, I understand that. Yeah. So yeah, I've been asked to sort of backport, for example, the normalization algorithm back into the Unicode standard. I just put a link to the library, right, and go. But like, it's yeah, I don't know. Like if so I'm doing all these packages myself, right? Like the entire suite, basically, like 50% of my time, also while doing also other things, like whatever other Go stuff. So it is going pretty slowly. So the advantage of doing it all, you can actually see the connection between everything, right? And try to design something in unison. So there is an advantage to doing it, but I just don't have bandwidth anymore to like write too much of this up, right, in official documents. But so what does work though is like, for example, the language matching. I'm really iterating with Mark Davis, one of the main Unicode guys, right, to sort of come to a, you know, middle way between the Java and the Go implementation. So yeah, so that happens. Yeah. Any other questions? All right, thank you.